In this lesson, we're going to be writing equations in slope-intercept forms. Remember, slope-intercept form is y equals mx plus b. Basically, whatever equation you're given, we want it to look like this, y equals mx plus b. Write each equation in slope-intercept form. Keep in mind, your goal here is to make each equation look like this. So, here we go. We've got y plus 5 equals 2x. Let's compare this with our goal. In our goal, we have y equals all by itself here. So we don't want this 5 next to the y. We want this y by itself. We can go ahead and subtract 5 from each side. That's going to get rid of that 5 over here, giving us y equals 2x minus 5. And if I compare that over to my goal, y equals mx plus b, I've got y equals 2x mx plus b minus 5. Bingo. Here we've got 3x plus y equals 7. Again, we don't want this 3x next to the y. We want that y all by itself on one side. To get rid of that 3x, let's subtract it from each side of the equation. That's going to leave us with y equals 7 minus 3x. All right, we're almost there. We want y equals mx plus b. It looks like we've got y equals b plus mx. These two terms need to be switched around. Well, we know that addition is commutative, meaning that we can switch terms around without it affecting the answer. For example, 2 plus 3 equals 3 plus 2. We can switch those around, and we can switch these around. And if we do that, we're going to switch this 7 and the negative 3x, giving us y equals negative 3x plus 7. Again, all we did is switch these two terms. That leaves us with y equals negative 3x mx plus b plus 7. Bada bing, bada boom. Alright, go ahead and brace yourself. This one's a little bit tricky, but not too bad. But it's really going to be important for you to get this. So here we've got 2y minus 3x equals 12. Again, we want y equals mx plus b. This time we've got a coefficient, a number next to the y term. We'll continue just like we did before. We definitely don't want this 3x term next to the y. So let's go ahead and add 3x to both sides. Doing that, I do know that I want my 3x to be in front of the 12, so instead of flipping it around, I'm just going to go ahead and write the 3x plus 12 right from the start. That gives me 2y equals 3x plus 12. Now, looking over to my y equals mx plus b, I don't want a coefficient next to y. I don't want anything next to y. That means I don't want this 2 next to the y. Since we have 2 times y, we're going to go ahead and divide each side by 2. These 2's are going to cancel each other out, leaving us with just the y, which is what we want. But then we're going to be left with this whole mess here, 3x plus 12 divided by 2. Here's something I want you to take note of. When we divide this whole side by 2, what we're really doing is dividing each individual term by 2. Doing that, we can write y equals 3 divided by 2x plus 12 divided by 2. Again, just splitting this 2 up between each individual term. We are always going to want to check if we could simplify the fractions. This 3 halves is already simplified, but this 12 halves, or 12 divided by 2, can be simplified to 6. That's going to leave us with y equals 3 halves x plus 6. Ka-ching.